Okay, students, I hope all of you have had a good theory session and completed it. Now, with the theory session, you may not be able to score until unless you don't apply that concept into the latest trending questions, because every day there is a change in question pattern, there is a way of questioning, framing of question is every day it is changing, but concepts are same. Okay, so first session we have completed to clear your crystal clear concepts. Now we are here into the new session, that is question session, where we are going to apply that concept as per the latest pattern questions. So I will be covering all the all the model of questions. So that session is also important, and this session is also important for good score and for your bright future. Okay, so at VIJ CHEM we always strive to give you a good thing as per the latest and shortcuts tricks. So that's why I expect all of you should inform your friends, relatives who are in need of the good education. Okay, so let's start with the session. Be ready. I hope everybody have one pen and notebook to note down the question. After every question, I will give you some time. Otherwise, you can pause the question, try to solve it on your own, then confirm with my video explanation. Okay? Okay, start. Okay, let's start with the very easy question, and don't think that this type of easy question only will be discussed. Okay, I will be chronologically arranged. All questions are chronologically arranged, that every model is covered as per the level it is arranged. Okay, so we can start from the zero and we will make you confident in this topic. First question is the ratio of energy of photon of 2000 angstrom wavelength to that of 4000 angstrom wavelength. Okay, so this energy we have to divide, that is energy of 2000 angstroms wave divided by energy of 4000 angstrom wave. That ratio we have to give. Is it understood? So can you do it? Give it a try. If it is okay, then nice. Okay, we will improve that level of the question. Okay. Okay, now listen carefully now. Energy is equal to Hc upon lambda. Energy is equal to Hc upon lambda. Here, first we will take 2000 angstrom here, and here we will take 4000 angstrom. This is the energy corresponding to 2000 angstrom. This is the energy corresponding to 4000 angstrom. So you can see they are reciprocal. So this and this will get cancelled. So 4000 angstroms. Okay. What will be this? 4000 divided by 2000. You will left over, that is equal to 2:1. Otherwise, answer is 2. Okay. So 2 means 2:1 or 2/1. So what is the answer? Fourth answer is correct. Okay. Okay. Here we are with the another question, somewhat difficult as compared to previous question. Okay. So likewise, only I will be improving the level. Don't worry about the level. We will reach up to the maximum level, so that even JRF question also you will be able to crack this type of topic. Okay. So here a gas absorbs a photon of 355 nanometer. How much nanometer? 355 nanometer. Absorbed by one, but emits in two wavelength. Absorption is one, but emitting in the two wavelength. Okay. So one wavelength is given, another wavelength you have to find out. Is it understood? So now I think you can do it or not. Okay, give it a try. Let's see. Okay. Tried? Okay. Now listen carefully. The main problem with the wavelength is not an additive quantity. Okay, 355 is not equal to 680 plus something. Even if you try also, initially you will come to know this is more than this. Why? Because E total is equal to E1 plus E2. Okay. E total is equal to Hc upon lambda. This lambda is equal to Hc upon lambda 1 plus Hc upon lambda 2. Okay. So we have this lambda, we have this lambda, we have to find out this lambda. Okay. Okay, Hc upon lambda is equal to Hc upon lambda 1 plus lambda 2. Here, what are the two things are given? This you have to find out. Okay. Now, this Hc, they are all not required. You can take it a common and cancel out. So, finally, what we will have 1 upon lambda by 1 upon lambda 1 plus 1 upon lambda 2. In 1 upon, even you can keep the units also same because options are given same, given information also same. Okay. So what I will write, 1 upon 355 is equal to 1 upon lambda 1, 680 plus 1 upon lambda 2 you have to find out. Okay. So what I will do, 1 upon lambda 2 is equal to, I will take this this side, this side. Okay. So 1 upon 355 minus 1 upon 680. Okay. See, 1 upon lambda, 1 upon 355 is equal to 1 upon 680 plus 1 upon lambda 2. Okay. Now 1 upon lambda 2 is equal to 1 upon 355 minus this that side. Okay. So like this, what you can do on simplification, on simplify you can do it or not. Okay, no problem. I will do it so that you should come to know the clear answer. Okay, so lambda 2 is equal to, okay, 1 upon lambda 2 is equal to 355 into 680. Okay, here it will be 680 minus 355. So lambda 2 is equal to 355 into 680 whole divided by this one. 680 minus 355. Okay, so can you do the simplification? If I'm doing the simplification, I got it 743. Okay, so I think you will also get 743 only. Procedure, it should be understood, and calculation you can do it any point of time. Okay, ready for the next? Okay, we are into the next third question and different model. Every question you will find a new model. Okay, old model is not available in VIJ CHEM. Okay, so iodine molecule dissociate into atoms after absorbing. That means we are giving a radiation of light of 4500 to, like this is big iodine atom. This is another big iodine atom. They have their bond. Okay. So when light enters, light is in a form of the energy. By absorbing, this light is how much? 4500 angstrom wavelength. Then they broke into atoms. After breaking, they are moving with kinetic energy. They are moving with some kinetic energy. Okay. So what is that kinetic energy? We have to calculate. Okay, here their bond energy is 240 kilojoules, but we have given some energy. Out of that, that they are moving with some velocity. Because of that velocity, they have some kinetic energy. Okay, so what is that kinetic energy? You have to find out. Is it understood? You have to be very careful with this. Bond energy is equal to 240 kilojoules per mole. Okay, so try to solve this question keeping that in mind. Okay, ready? So I am planning for this question solution in 4 steps so that everything should be clearly understood. Okay, so here bond energy is given, but the problem is that bond energy is given per mole. Okay, so first let us convert the bond energy per mole into per molecule. Okay. So what is the bond energy given already? It is given as 240 kilojoules. First of all, 240 kilojoules. That's why 10 to the power of 3. So these are required by not one bond. It is by 1 mole of bond. So 6.023 into 10 to the power of 23. Then you will get energy required per molecule. Okay. So this I have simplified. I got it 3.984 into 10 to the power of minus 9 joule per molecule. This is per molecule. Is it understood? Why is this 10 to the power of 3? Because kilojoules. And why this Avogadro number? This is 1 mole. Okay. So actually this much energy was only needed. But we have given some energy. But that energy also not in the form of the energy. Information is given in terms of the wavelength. So it's our courtesy to convert into energy in joules form. Okay. So for that, what form we will use? Hc upon lambda. Okay. H value 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8. And wavelength, what it was given to us? 4500. Angstrom, it is given 10 to the power of minus 10 meters. Okay. So this energy was given, this energy was required. Okay. So when I calculated, I got it as 4.417 into 10 to the power of minus 19. See, here only you can understand. This was the given required energy. We have given this much energy. Extra we have given or not. So what is the extra energy? That will be converted into kinetic energy. Okay. So kinetic energy is simply subtracting given energy minus required energy. So 4.417 into 10 to the power of minus 19 minus 3.984 into 10 to the power of minus 19. Sorry, it is minus 19 minus 19. Okay. So on subtracting, I got it as 4.33 into 10 to the power of minus 20 joules. Okay. And there is one more gist, one more trick, and sorry, one more twist. Here question is about not per molecule. Question is about per atom. So this much energy was given to how many per molecule? Each molecule contains how many atoms? 2 atoms. So kinetic energy per. So we require the energy, kinetic energy per atom. Okay. So this energy is per molecule. How you will change it? You will change it by dividing by 2. Okay. So this answer divided by 2. Why divided by 2? Is it understood? Many students got it wrong just because of this concept only. Okay. So on simplification, you will get it as 2.165. 2.165 into 10 to the power of minus 20. Okay. 2.165 into 10 to the power of minus 20. This is the correct answer. Energy, kinetic energy of per atom of iodine. Kinetic energy of per atom of iodine. Okay. Is it understood? Ready for the next question? Okay. Okay, this question is according to the latest pattern of integer type question. Okay, so where work function of some metal is given here, and on these metals, on all metals, same wavelength is projected. What is that wavelength? 300 nanometers. And how many of this metal will give you photoelectron? Question is, how many of these metal will give you photoelectron? Is it understood, students? Okay. So how you will do? Are you planning something? You can try yourself and then check with my magic and fastest answer. Okay. So are you ready? Do it, then cross check it. Okay, have you tried? Now I am explaining in the easiest way of calculation. Okay. First, what we will do is we will convert this energy into, sorry, this wavelength into energy. That too you will convert into electron volt. Okay. So what is that formula? E is equal to Hc upon lambda. Okay, 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 divided by 300 into 10 to the power of minus 9 meter. But the answer will be in joules. Answer will be in what? Joules. You have to convert into electron volt. What you will do and how you will do. Okay, you will write same thing divided by, we will divide it by 1.6 into 10 to the power of minus 19. Then you will get as a electron volt. I have done it and I got it 4.16. How much I got? So this much energy we are giving to them. What we are giving to them? This much energy we are giving to them. Okay. So the given energy should be more than the threshold energy. Will it emit? No, it requires 4.75. We are giving 4.16 only. So it requires 6.3. We are giving less, 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 less. Okay, 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 and okay. So lithium, sodium, potassium, and magnesium, four metals are giving photoelectrons. So answer, integer type answer will be 4. Okay. So this can be more than one correct in advanced also. So all pattern you should be aware of it. Okay. Okay, here comes another wonderful question. Photoelectric emission is observed from a surface for a frequency of nu1 and nu2. Metal is same, but two different frequencies are irradiated. Okay, and this frequency is more than this. And maximum kinetic energy for the nu1 is Ke1, maximum kinetic energy for the nu2 is Ke2, and they are in the ratio of 1:k. Then he is asking about threshold frequency nu0 in terms of nu1, nu2, and k. That is the question. Very difficult to understand, but if you understand, then very easy. Okay, so try, give a try, see how much options are very disgusting, very close, all appear to be same, but they are not same. Okay, carefully you should do it. I think you will be careful and fast. Okay, try, pause the video, try. Okay, already we know the formula H nu is equal to given incident free energy will be utilized first to remove the electron H nu 0 plus remaining will be converted into kinetic energy. But here the question is more related to kinetic energy. That's why I am taking kinetic energy as a reference. Kinetic energy is equal to H nu minus H nu naught. So here two different frequencies are given. So I am writing in terms of the frequencies. Ke1 is equal to H nu 1 plus, as metal is same. You have to be very careful. Same metal irradiated with the different frequencies. So kinetic energy will be different, but not nu naught. Nu naught is fixed for fixed metal. Okay. So Ke1 is equal to H nu 1 minus H nu 2, and Ke2 is equal to H nu 2 minus H nu naught. Is it understood, students? Okay. So now what is given to us? Ratio is given. So Ke1 by Ke2 we will do. Are you understanding? H I will take common and just cancel it out. H nu naught. Okay. And this will be nu2 minus nu naught. Is it understood? And what is the ratio given? Ke1 by Ke2. I think already it is given as 1 by K. Okay. Our intention is to find out nu naught. So what I will do, I will just cross multiply. Okay. Nu2 minus nu naught is equal to K into nu1 minus nu naught. Okay. So nu2 minus nu naught is equal to K nu1 minus K nu naught. Up to here, is it understood? So should I erase this one? Very easy question. Main problem is what is given, what he wanted to ask. That only the main problem. Okay. So if I bring this side, K nu naught. Okay. minus nu naught. I will take that side. K nu 1 minus nu 2. Okay. So what I will do, nu naught, I will take it common. So K minus 1 is equal to K nu 1 minus nu 2. Nu naught is equal to K nu 1 minus nu 2 by K1. K minus 1. Okay. So is there any option like this? Very good. Which option is correct according to this? Which option? K nu 1 minus nu 2 by K1. So that is B option is correct. In the given question, which option is correct? B option is correct. Nu naught is equal to K nu 1 minus nu 2 by K minus 1. Okay. So is this understood? This is the way you have to solve different varieties of question. Okay. Okay, students, another wonderful different model question is here in front of you. Will you be able to crack it? Okay. See, work function of a metal is 4 electron volt to emit a photoelectron. To emit a photoelectron, okay, of zero velocity from a metal. This is the keyword. What is the zero velocity stands for, how it is going to affect our calculation. For that, if you gone through my video lecture of photoelectric effect, then you will be purely understanding. That's why I will emphasize on the words which are going to affect the question. Zero velocity. At zero velocity, incident energy is equal to critical energy, work function, or threshold energy. So this energy itself is E. Is it understood? So electron volt is given. So better to use which term? I told you in my theory session. Very good. Work function. Okay. When electron volt is given, better to use what function? Work function. Okay. So E is equal to E naught. So wavelength we want. The main problem is that here it is given as a work function 4 electron volt. So better to convert it into joules. 1.6 into 10 to the power of 9 minus 19 joules. So this is the energy. This is energy. Now we want to convert this. We want to find out wavelength. So what is the formula? Hc upon lambda. Okay. So lambda is equal to cross multiply Hc upon 4 into 1.6 into 10 to the power of minus 19. So H value every student must be knowing 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 divided by 4 into 1.6 into 10 to the power of minus 19. So this calculation part, will you able to do it? Do it and tell me whether you are correct or not. I will tell you. Very good. I have done and I got it as 3100 angstrom. How much I got? I got 31 angstrom. So what is my answer? My answer is D answer. And my answer matches with correct answer. What about your answer? I also want that your answer should also be B. If there any mistake, just to go through it once again, what mistake you have done. Calculation mistakes are not at all allowed. Okay. So let us see for the next bright question. Okay, we are here again with one more different model recent question. Okay, so this type of question, all questions I have selected are either recent questions or the questions which you are going to face in your actual exams. Okay, so lambda naught is a threshold wavelength, lambda is the incident wavelength, and velocity of photoelectron we want to find out. It is just like a derivation part only. I think you will be able to do it or not. Okay, give it a try. The main problem with this, see how much close, how much complicated options are there. There is no guess chance. Okay, So simple derivation you should be doing. Do it and I will tell you the correct answer. Okay, tried. Now see my solution. My solution is final solution, correct solution. Okay. So Hc upon lambda naught is equal to Hc upon lambda plus kinetic energy. So better what I will do, I will write it in the form of the half mv square. Why I am doing like this? Why I have selected lambda? Because question is in terms of the lambda and answer is in terms of the free velocity. Okay. So what I have to do, half mv square is equal to hc upon lambda minus hc upon lambda naught minus lambda. As a common man, everybody after looking at it, what you feel, that feeling should come from you. Okay, good. You have to take common. Very nice. Okay, and after that, okay, lambda minus lambda naught by lambda into lambda naught. Okay, this is correct. Half mv square. We are concerned with the velocity. So 2hc upon m into lambda minus lambda naught lambda into lambda naught. Okay, but we don't v square. We want v is equal to square root of 2hc upon m lambda minus lambda naught lambda into lambda naught. Okay, so this is the v, velocity of electron. Okay, so I think am I correct or not? Half mv square. Oh shit, shit, shit. This is not, this is not, and this is not. Okay. So final answer is square root of 2hc upon m into lambda naught minus lambda by lambda into lambda naught. See, overconfidence is always dangerous or not? So I was overconfident. Okay. Incident wavelength should be here. Threshold free wavelength should be here. Okay. So this is a live example. Overconfidence kills you. Okay. So as per this, which option is correct? C option is correct. Which option is correct? C option is correct. Okay. Ready for the last final touch with a good question. Okay, another final model question. A certain metal was irradiated with a light of frequency 3.2. It is 3.2 into 10 to the power of 16 hertz. The photoelectrons emitted has twice the metal was irradiated. Okay, had the twice kinetic energy. Sorry, here it is twice the kinetic energy. Okay, when metal was irradiated with light of frequency. That means metal is same, one and same metal another frequency. Two different frequencies are irradiated. First frequency was 3.2 into 10 to the power of 16. Second frequency was 20 to the power of 16. Both electrons have given with the different energies, so their kinetic energy will also be different. How much this energy, kinetic energy of the electron which is coming out by this frequency is twice that of this. Now question is not about that. Question is what is the threshold energy of this metal? When this is going to be twice is purely depends upon the threshold energy of the metal. Will you able to solve? Let's see. Okay, see my way of simplifying. Kinetic energy is equal to given energy minus threshold energy. Okay, but in this question, what is given in terms of the frequency given? So kinetic energy, I will keep it as it is. I will write as a h nu minus h nu naught. Okay, and here two different frequencies are given. Let us take Ke1 is equal to h nu 1. Metal is same, so nu naught will be same. And Ke2 is equal to h nu 2 minus h nu naught. Let us take equation 1, equation 2. Is it understood, students? So what you have to do now? Just divide it. Good. So much cute students. How students? Cute students are there. Okay. So KE1 by KE2, you can take common h and cancel it out. Not required, cancel. Required, keep it. Okay, don't dump the things around it. And here it is given, this kinetic energy is twice of this. So 2 will get cancelled or not? 2 into nu1 minus nu0 divided by, sorry, nu2 minus nu0. Is it understood, students? Very good. 2 into nu2 minus 2 nu0. Cross multiplied and made internal multiplication also. Nu1 minus nu0. Okay. So this part, can I erase this? Good. So finally I'm getting it as 2 nu2 minus 2 nu0 is equal to nu0 minus nu0. So what I wanted to do is, I wanted nu0 or not. So if I take that side, 2 nu0 minus nu0 is equal to 2 nu2 minus nu1. This that side, this side. So this is nu0 is equal to 2 nu2 minus nu1. Finally, we reached the destination. Which nation? Destination. Okay. So 2 into nu0. Nu0 is, sorry, nu2 minus nu1. What is nu2 here? 2 into 10 to the power of 16. Okay. So nu2 is, I think, 2 into 10 to the power of 16. What is the nu1? 3.2 into 10 to the power of 3.2 into 10 to the power of 16. Okay. So this will be 4. 4 minus 3.2, 0.8 into 10 to the power of 16. So as a stylish answer, this is the final answer. 8 into 10 to the power of 15. These are units are hertzes. This is the frequency. Is it understood, students? Okay. Bye bye. I think now all concepts, all you are master in photoelectric effect and Planck's theory. All questions covered, all theory covered with graph also clear explanation is done. So today what you will do, you will subscribe. You will ask to subscribe one of your friend. Daily one subscriber should increase so that he should be thankful to you for giving a good suggestion. Okay. And I hope all of you have subscribed it now and pressed bell icon. Bye bye. See you. Stay happy from VIJ CHEM family. Okay.